Let me go ahead and start. So basically what an average rate of change is it just means you're finding a slope of a line that passes through 2 points. Okay, if you're going to take calculus, I know a lot of you have to do that. You'll deal with the slope extensively. It's a big deal in calculus. So you're using the slope formula, and the slope formula, you can think of it as change in output over change of input. The best way is just how are the y's changing? That triangle stands for delta. That's just we use that in math to talk about how things are changing. So it's the change in y over change of x. What we're going to do mostly is work with the slope formula, y2 minus y1 over x2 minus x1. Okay, so we're going to go ahead and I'll go through and review these first things. The first thing I want to do is just look at a graph and find an average rate of change. So I'm always going to give you 2 x values on this. Okay, so let's go ahead and if we identify x equals -4, on that, there's the point. I'm just going to label that point as -4, 1 like that. Okay, you go to the second point, we have x equals -1. That is the point, and I remember doing this in class the other day, and that's -1, 3. Okay, like that. Isn't it what? Maybe you're right. Let me see. What did I say last time? Did I say 0? It should be 1. Of course, I couldn't see as well last time. It looks to me like that's clearly a -4, 1. I mean, it is. Nobody caught that. I'm going to go ahead and do this the right way. It's -4, 1. Okay, and you can leave, if you were here last time, you can leave what you had. Okay, but really those are the 2 points. And what you're doing is when you do an average rate of change, you're just doing the slope of the line that connects the 2 points. Okay, so you can kind of write this out like this. You're going to see me just putting AROC. That's my abbreviation for average rate of change. So we're going to do the formula y2 minus y1 over x2 minus x1. Okay, if you can do your arithmetic right, there's absolutely nothing to it. What I always recommend you do when you're using a formula, this is something I highly recommend, that you just replace the variables with parentheses. So you don't have to do that, but it's a good habit. Now, you're going to do the y values in the order you want to. The y values are going to be these things here. The 3 and the 1 are the y values. Okay, so I'm going to choose to go 3 minus 1. Okay, the change in y is 2. That's how far 1 and 3 are apart. Okay, yeah. How did I get what? Okay, well, the y values are just looking at how high up on the graph you are. So when x is -4, it looks like I'm up 1. Okay, and when x is -1, it looks like I'm up 3. Okay, I'm just writing the points, yeah. Yeah. Okay. All right, so now we just work it out. Now, what you're going to do is you're going to do the x values in the same order. Okay, so we got -1, -4, so I'm going to pop that in. I got -1 here, minus -4 there. Make sure that you do your subtraction in the same order. Don't mix them up. Okay, so what that's going to give me then is 3 minus 1 is 2. That's your change in y is 2. Your change in x, you can write another step if you need to here. How do you handle a minus minus when it shows up? Addition. So that's -1 plus 4. So that's 2 over 3 would be the average rate of change. What did I get last time? I guess I got something different because I didn't do that point right. Okay. All right. I didn't even catch that. That's okay. All right. Okay. So that's it. And really all you're doing, the other thing I want you all to see on this too is a slope of 2/3. You can think of a slope as a rise over a run. If you look at this, if you're going from this point to this point, doesn't it look like you're just going up 2 and over 3? Yeah, that's what the slope is. So you're rising 2 and then running 3 to get to that next point. Okay, it's nice to know that connection. That's what a slope is. Okay. All right, let's see if I did this one right last time. So we have x equals 0. So what we'd have here is I'm going to put a dot there, and that point right there is 0, 600. And again, I'm getting the y value. That's what you were asking, Daniel. It's just that point is up 600. That's how I'm getting that. Then you take the second value, 40, and then that point looks like it is 40, and it looks like it's up 200. Okay, like that. I know I did that one right. Okay, all right. So again, what we do is the same thing. We do average rate of change. So average rate of change, we'll just do the formula y2 minus y1 over x2 minus x1. Okay, like this. And again, it's your choice what order you do this in. Okay, I'm going to choose to go 200 minus 600. I could do it backwards if I wanted to, but that will force me to do the x's in the same order. So that's going to force me to go 40 minus 0 like that. Okay, the y's have to be on top, the x's on bottom. Simple arithmetic. So what we get here is negative 400 divided by 40. It kind of looks sloppy there. I'm not seeing this very good today. So anyway, that's negative 10. So you would have an average rate of change of negative 10 on that then. Okay? You guys understand what's going on? Okay, you got to know how points work, and they got to know the formula. Okay? All right, let's try some problems on the next page. Right? Has everybody got this down? Okay, all right, very good. Go to the next page and just kind of compare your answers on these, if you will, and kind of try them yourself. But if you want to put the answers up here, it looks like when I was checking papers, 4/3, I think as long as you got the points right, you were okay. So your points were 2, 3, and 5, 7. Okay, and I think most of you did 7 minus 3 over 5 minus 2. But I want you to notice if you did 3 minus 7 over 2 minus 5, you would get negative 4 over negative 3, which is still 4/3, isn't it? So it's up to you what order you do them in, but the thing is you have to be consistent. The order you do the numerator in, you got to do the same in the denominator. But it's your call on which order you want to do it in. Okay, be flexible. Okay, the next one, the 2 points were 0.25 and 5, and then 1, 2. Those are your 2 points there. So I chose to go 2 minus 5, and then 1 minus 0.25. And I just did this on the calculator, so you get negative 0.3 divided by 0.75, you get negative 4. Okay, and you can do that on the calculator. Okay, all right. Is there any problem with that? Okay, one other thing that you guys want to know too is there's a reason why this average rate of change is positive. Does anybody know why? By looking at the line? It's going up. Okay, if your line goes up, then you have a positive rate of change. This one's negative. How do you know? Your line's going down. Okay, so if you're decreasing like that, that's a negative average rate of change. Okay, you okay, Daniel?
Why is Y2 a 2?
Okay, why is this a 2? Because when you go to x equals 1, you're at that point on the function right there. And that y value is 2. Okay, so what I would
be
say,
Y2, wouldn't it?
it doesn't matter which one is y2 and y1. That's up to you. So you could say 2 minus 5, or you could say 5 minus 2. That's your call. But when you decide what order you do it in, like since I decided to go 2 minus 5, I do the x's in the same order, because if I don't, you'll mess up the answer by a negative. Okay? Right. So the only thing I was seeing, maybe not writing the y values right, I was seeing that some. Okay? Does anybody have any questions? Okay? All right. So average rate of change is a slope. If you know the slope form, you won't have any trouble doing that, I don't think. Okay, so now what we're going to do is I'm not giving you a graph, so we're going to do an average rate of change. Then I'm going to let you work with your graphing calculator to work with your graphs quite a bit, because we don't really, in this class, haven't done any graphing of any type yet, except the piecewise functions. So what we're going to do is, step 1 is we need to find the y values. Okay, And finding the y values is evaluating a function. So I gave you x equals 0. So we're going to do f of 0. F of 0 just means plug into the function. So where you see x, replace with 0. All right, so we are evaluating the function 3x minus 5. Plug in a 0. Work out the arithmetic. You can do it in your head. You can check on a calculator. That gives negative 5. So what that gives is that gives you a point. You would get the point 0, negative 5. When you're finding an average rate of change, you need to have 2 points. Okay? I have to give you x. I don't have to give you y. I could, but I don't have to. Okay? Then what we're going to do is take the x equals 4. So we're going to do f of 4. F of 4 means plug into the function. Again, that function is 3x minus 5. So you're going to do 3 times 4 minus 5, which is 12 minus 5. So that's equal to 7. Okay, so your second point would be the point 4, comma 7. Okay, so what you got to do is get 2 points. And when you did the last problems that I had you do, that's what you did. You got 2 points, then you did your slope formula. Okay, is everybody okay with how I get these 2 points? Okay, now we're going to find the average rate of change. Okay, the average rate of change, the formula says y2 minus y1 over x2 minus x1. The point is it doesn't matter which one is y1 and which one's y2. You just need to know that the y values are the second numbers. So I'm going to choose to do it in this order. This is my choice. I'm going to go negative 5 minus 7. Okay, the y's are going to be on top, changing y's on top. And that's going to force me to do the x's in exactly the same order. So I'm going to do 0 minus 4 like that. Okay, so I'm just choosing to go negative 5 minus 7. That forces me to go 0 minus 4. Okay, so that means I'm going to get negative 12 over negative 4. So what's the answer? 3. Okay, so we end up getting the average rate of change is equal to 3 on this. Now there's something that I want you to see on this problem, and it depends on your background, I think, is I already knew what the average rate of change was without doing that. I'm curious if anybody knows. What do you think? Yeah. Okay, this is a line, y equals mx plus b. That slope is 3, and that's what an average rate of change is. I think you'll see this on web work. I mean, I'd like you to do the problem this way, but yeah, you could do that automatically in your head because that's a line. What's happening, I think, in college algebra, we hadn't done that much graphing yet, so you'll kind of make these connections as we go. But again, I got 2 points, and I did the slope formula. That's what an average rate of change is. Are we okay? Okay, all right. Now get your calculator out. I'm going to have you use your calculator as much as possible. Does anybody need to borrow a calculator? I don't know how many I got, but it would be helpful. You guys share, I guess. You need one? I mean, you can share if you have to. I mean, just the more the better, because we're going to do a lot of graphing today. I don't think I have any other calculators with me today. Okay, so just do this. And when you graph something, you go to the y equals button. You can clear off whatever you have. And then we've done this, but we're going to do this throughout the semester. Don't forget that your variable button is right there. If you need to put an X in, that's your button right there. So you just put in, yeah.
I'm trying to put in another value like t or something. How do you?
Don't do that. Don't do it. If you're graphing something with t, don't do it. Just use x.
How could I use it though? Because I was trying to hold it or press the arrows and.
Don't do it.
Maybe for another class.
Okay. Okay. No, really, when you change that to t, that's a totally different thing. That means something totally different. Or if you use theta, so I won't go there. If it's for another class, see me after class and I might be able to help you. Okay, but I don't want to tell you anything wrong. So for this class, college algebra, you're always going to use x. Okay, all right. So now I put in the minus 5 and make sure you do the subtract 5 like that. Okay, so you got to get that in. Now, what I want to train you to do when you graph is don't just press the graph button, go zoom number 6. Develop the habit of doing that because it'll put it in a standard window, okay? Now, we're going to do some graphing, throughout the class here today. So the other thing that you want to do, you can see that it's a line, is go to your table of values. So if you go second table, like that, then you can get as many points as you want. So we go second graph, and now just pick any of these points you want to, okay? Because when you're plotting using a calculator, you want to type it in correctly and get whatever points that you want to use. So what I'm going to do is I'm going to use this point 0, -5. I'm going to put that one in there, and I'm going to pick another one. I'm going to do like 2, 1. It's up to you what you choose, okay? And then you just connect that into a straight line like that, okay? So I want you guys to know how to use graphing calculators really well. I'm going to do a lot of that this semester because I find a lot of times my calculus students are in that class and they don't have the skill they need for calculators. So we're going to graph a lot. And it's a great tool to help you learn that stuff too. Okay, any question about what I did on the calculator? Important if you have questions on that so we get the basics kind of on track here today. Okay, let's go to the next page and let's start this one off with a graph since I got my calculator, okay? Because I'm really wanting you to do the graph to help you to check things and understand things better. So you go to your y = button and then just put in 4. Make sure it's a subtraction symbol. Then x, there's your variable, and then to the second power. Okay, like that. Okay, that's going to give you a curve. We call that a parabola. Okay, if you want to go zoom 6, that'll give you your graph. Okay, and you can get points from your table of values if you want to, or you can sometimes see the points pretty clearly on the graph anyway. So I'm going to go second graph, table of values, and I'm going to find some points. So what I'm seeing is like -2, 0. I see a +2, 0. I see 0, 4. Just try to get enough points so that you have a pretty accurate graph. All right. All right. Are we okay with the graphing calculator stuff? Yay or nay? Okay. All right. Now we're going to do this problem exactly the way we did the last one. Okay. Step 1 is we need to find y values. Now I'm going to show you 2 ways to do this. Okay. First of all, what we're going to do is I gave you x is -1. So we're going to do f of -1. So plug into your function. Your function is 4 minus something squared. So do that. Okay, so we're going to work that out. That will be 4 minus 1 because -1 to the second is 1. So you get that 0.3 like that. So your first point really has an x value of -1 and a y value of 3. Okay, now look at the graph we did. Does it look like that's on the graph? Left 1, up 3. Does that kind of look like it's there? It's there. I didn't draw a super accurate graph, but it's definitely there. So let's go ahead on your graph and just put a dot there and label that -1, 3. Okay, and you can check that on the calculator. You can look at your table of values, and there's -1, 3 anyway, see? Okay. Then I'm going to do the other y value, f of 3. So I'm going to do 4 minus 3 to the second. So that is 4 minus 9. So that's -5. So that gives you your second point. X is 3, y is -5. Now look at the table of values I got. You can see 3 -5s there. So label that point over 3, -5. Like that, okay? Now, remember what an average rate of change is it's just the slope of this line. Is that going to be a negative slope or a positive slope? Which? Going down, what makes sense? Negative, negative, negative. That's a negative slope. If your line goes down, it's a negative slope. If it goes up, like that, it's a positive slope. Okay, it's just nice to know those kind of things. All right. Now, so see those things right there, you want to do it with arithmetic. You want to show your work that way, but you can check and see if you're right. You look at your table and see if these are the right points. You got the power to do that, okay? All right, now let's go ahead and let's crunch this out then. And again, the average rate of change, I'm not going to keep writing the formula up. Just kind of learn to set it up this way. Something minus something over something minus something. Using parentheses is a good habit. And again, it's your call on the order we're going to do this. The y's are 3 and negative 5. So I'm going to choose to go this way. Negative 5 minus 3. I'm going to make that choice. Okay, and I'm going to do the x's in exactly the same order. So if I go negative 5 minus 3, then I have to go 3 minus negative 1. Okay, like that. Okay, work out the arithmetic. That would be negative 8 in the numerator. That would be 3 plus 1 in the denominator. That's negative 8 over 4. So your average rate of change on this problem is negative 2. It's negative. We knew it was going to be negative because it's going down. Okay. So what I'm wanting you to do with these problems is get a good graph with your calculator and then be able to find the y values so that you can use the slope formula. Is there questions? Okay, go ahead and work a couple of problems out. Let's see if you're getting the hang of how to do this. Okay. Use your calculator on the graphs, and I'll kind of walk around, and if you have individual problems with your calculators, I'll kind of help you with that. But you need to be able to use your calculators good in this class. Up here now. I need to get this thing back on, don't I? Okay, so the first one's negative 1. Now, I want to show you all a couple of things on your calculator because the number one thing I was seeing is students messing up with getting those y values. And part of that is how you write it. When I am evaluating 4x minus 2x squared, I use parentheses with a variable step. Right? And you end up getting the 2 points, negative 0.5, negative 2.5, and 3, negative 6. So if you don't get your evaluation right, you don't get those y values right, you're going to struggle to get it right, okay? So what I ended up doing, what I chose to do was to go negative 6 minus negative 2.5, and then 3 minus negative 0.5 like that, okay? So you end up getting negative 1 on that. Now, this would be very helpful. I don't want you guys to get totally dependent on your calculator, but I want to show you all something. This would be very helpful to you. So I want you all to do something on your calculator. I didn't show this to you, but I want to show it to you now. If I can get my calculator behaving here. Okay, everybody should do this because I didn't teach you how to do this, but I'm going to now. Go to your calculator and put in the function y1, just go ahead and put in 4x minus 2x squared. And you have to do a better job on the arithmetic of getting those y values, because if you don't get that right, it messes the whole thing up. So if you get your graph, I want to show something, and you want to see if this works on your calculator. So that's your graph of the first function. You have a trace button right here. So an easy way to tell you're right is to do this. Try this on your calculator. You got to get your graph up on that. If you type trace and then put in negative 0.5, then it's going to spit that out. It's giving you that negative 2.5 like that. So you can learn to use your calculator to check and verify that that arithmetic is right. Learn to use that trace button. Now you can go trace 3. And look at that, it's negative 6. Learn to use that trace button when you're graphing things, because that was the biggest issue that I saw on the problem, is not getting the negative 2.5 or the negative 6, okay? And then you're ready to go to your slope formula when you're doing that, okay? You guys understand what I'm talking about with trace? Learn to use that. It's a very helpful tool, okay? And on this second one, you could do the same thing. If you put in like the x to the third and like the minus 2x squared, and the -1 like that. Again, you can graph that. It seems like people's graphing calculators, you were doing a good job on that. But you can trace these things out too if you want to. So if you go trace -1, that would be -4. So your first point's -1, -4. You can trace at the 3, the other x value I gave you, and that would give you an 8 like that. Okay, you don't want to get too reliant on this because I'm afraid that if you don't practice the arithmetic skills, doing it by hand, then you're gonna never maybe develop the arithmetic skills you need to develop. But you can check those y values on your calculator. Okay, don't spend tons of time when you're doing homework trying to figure out where you messed up on your arithmetic. So now it's just a matter of going. I chose to go 8 minus -4. And then 3 minus -1. Okay, you could do that backwards, okay, and get the same answer. Okay, is there questions? Okay.
The second one, 3 plus 1 would be 4, so it would be 3 now, or just...
Hold on, you guys got 3 on the second one, didn't you?
Yeah.
Yeah, okay. Okay, that's kind of a bad error by the teacher. I'm so embarrassed, I'll never be able to face you again. 3 plus 1 would be 4, right? It's 3. Okay, all right, thank you. All right, any problems? Okay, all right. So that's when you're doing an average rate of change. That's what you're doing, is you're doing a slope. And you need to keep it simple. Once you establish what your 2 points are, then you use the slope formula. Okay, don't mess up on arithmetic. You got a calculator to check things. I could have even checked 3 plus 1 on my calculator, I guess, and caught myself. All right, let's go to the next page, and we'll go ahead and work on this. This is sort of pre-calculus information right here. So being able to look at a graph and telling where things are increasing and decreasing and writing an interval notation, I want to go ahead and go through that before we do our break here and just kind of get through this idea. So basically, I'm not going to get real technical about this, but a function is increasing on an interval where the y values are getting bigger. Okay, so one of the things I want to show you on this, like on this particular graph, right here where I'm highlighting in yellow, that would be where it's increasing. Okay, those y values are getting bigger. Just think of a graph as a roller coaster. You're going uphill, you are increasing. Now, when you name your interval, okay, this thing basically starts at -1 and it ends in 3. So that's why I'm saying we're increasing on -1 to 3. So you're naming that interval with the x values, okay? This is another thing that you should write on your notes, is always when you're writing these intervals, use parentheses. Don't ever use a bracket on increasing, decreasing. I'm not going to get into why that is in college algebra, but these are open intervals. Okay, there's a reason why, because of how they're changing, right? And then decreasing, okay, you're going downhill on the roller coaster. I'll highlight this in blue, and then again, just kind of see what I'm doing. Look at the x value. This decreasing interval starts at -5, then it ends at -1. Then it picks up again at 3, and then it goes on forever. So you're naming those in interval notation. Okay? Constant just means there's no change in the graph. So constant would be this piece right here that I'm highlighting kind of in green there. It just means it's level. Constant means the y values are not changing. So but notice the way I did constant was -infinity until I get to -5. So those intervals are always open intervals, and you're looking at the x value. But keep it simple, just roller coaster. Increasing's uphill, constant, like this, horizontal. And then downhill is you're decreasing, okay? So we're going to work on that a little bit and just make sure we got the language of this okay. Okay, so let's see increasing on the first one. So I'm kind of thinking of the roller coaster here. I'm going to highlight in yellow where I'm increasing. Okay, that's where the y values are getting bigger. Okay, now what you do on this is you want to name these intervals. So my x values are going by 1, so that looks like -3. That looks like 1. That looks like 4, like that. Okay, so increasing is going to be starting infinitely to the left, So that interval there is going to be negative infinity until we get to -3. Okay, you're looking at the x values right there. The other place is going to be 1 until you get to 4. Okay, like that. So that's how you write the increasing interval like that. Okay, decreasing, you would be going downhill. So it goes like that. Okay, and if you look at that, how are you going to write that interval? Where does it begin? Where does it end? -3 to 1. Good. Okay, so we're going to go -3 to 1 like that. Now that's the only place. Is this thing constant anywhere? Yeah, right at the end, it's constant. How are you going to write that interval?
4, positive infinity.
There you go. It starts at 4, goes on forever to the right. Okay, so we're kind of applying the interval notation things that we talked about when we're doing inequalities. Okay, any question on that? Okay, all right. So the next one right here, same thing. Increasing would be this little piece right here. How do you think you'll name that? X values. Where does it begin? Where does it end? -1 to 1, right? Okay, it starts at -1, ends at 1. Don't look at your Y values, look at your X values when you name your interval. Okay, so that's your increasing right there. Graph's getting bigger. It's going uphill. Okay, decreasing, I'll highlight those in blue. So how do you think you're going to name decreasing?
Negative infinity.
Negative infinity?
-1.
Good, okay. So that's your decreasing is negative infinity until you get to -1. Okay, and the other one is where to where. That looks like it's 1 until infinity. What do I put in between these two intervals? The union symbol. Anytime you got two intervals, you want to use that union symbol like that. Okay, so again, look at the x values. Here's where you're going up the roller coaster, -1 to 1. Going down from infinity because of that, negative infinity until you get to -1. Then starting at 1 when you're at that high point, then you're going downhill again like that. Okay, is this thing constant ever on that thing? No. Okay, it's never levels off. So we would just say constant. We would just say none. That's good enough. Okay. All right. I'm going to have you go ahead and just do a couple of these to see if you got this okay. Then we'll take a break here. Okay. And students generally do this okay as long as they understand how the intervals go. The increase, decreasing, we're not going to be technical about it. Just kind of think of a roller coaster, and that'll be good enough at this level. Okay, and I tried to highlight them, so you can kind of see, and I saw a lot of you doing that, just kind of highlighting it. So this first one, increasing, I did the yellow. There's 3 areas where it's increasing. -5 to -3. Again, look at the x values when you're naming your intervals. Okay, and then -1 to 1, and then 4 to 5. Okay, I tried to write those x values on there because that's what you look at, is you look at the x values when you name your intervals. Decreasing, I highlighted in blue, your negative infinity to -5, and then 1 to 4. Again, look at those x values when you name those, okay? All right, I saw several of you didn't see the 2 constant places on here. So those, I highlighted those in green. That's -3 to -1, and then 5 and forever. Okay, like that. So that's what you should have come up with, exactly like that. It doesn't really matter what order you put those things in. Like number 1, you could have 4, 5, -1, 1, then -5, -3. It's not wrong to do it that way, but develop the habit of doing things from left to right. Okay. And the last one, let's see, you were never constant. You were never at a place where the y values were staying the same. So increasing, there were 2 areas, 1 to 3, 4 to infinity, and decreasing forever to the left, negative infinity to 1, and then 3 to 4. Okay, like that. I think most of you did okay. I didn't look specifically at your answers. I was looking more at the structure of what you were doing. Okay? Now, does everybody understand that you're using the x values to name your intervals? That's the key. That's the key. Okay? All right, I'll leave these up here. Let's go ahead and take a break for 10 minutes. Just come back at 10 after, if you will. And then we got just a little bit more to do, and then we'll do as much as we can on 3-4 today, too. But I'll leave these up. Sure.
So I understood this. That was pretty easy. I don't understand what it's asking me here. Is it this whole equation?
Okay, we did that in class, so they're telling you that this is -3. They're saying f of x is -3.
Okay, so we just plug that in right there?
Yes, and what you're going to do is you're going to solve an equation. So you're going to say
Okay.
-3, I'll try to write on here, -3 equals -4 plus 3x. Okay, because you're going to leave that alone. They're not telling you what x is. They're telling you what that is.
Oh.
Now solve that equation, get x by
Well, you
itself.
have to
Add
move
4 to
that
both
over
sides.
and then divide. Okay.
There you go, good.
Thank you. Sorry.
No problem.
So I'm older, this is, I was wondering if there's anything else I could pick up.
Today, that's the only
That was
handout.
it?
Yeah, there was, you were here last, did you miss last time? Did you get your
No,
test back? I think
this was
so.
my test, actually. Several people weren't here, so I get the test back. Y'all did your test, you weren't here last time, Chris, I did your test. There's also, I did grade yours today.
Yeah, come up, if you got something.
How to do my subtraction or fractions. If I'm multiplying across, do I put a minus or a plus?
Well, the sign would stay the same. I'm just kind of looking what are you doing on this? Average rate of change?
Yeah.
Okay, so G of 3. Yeah, let me just see your pencil and I'll show you what you want to learn how to do. So yeah, you're doing the change in y's. Do you know what the common denominator is for those two? You're using 40. 40 will work, but it's not the lowest common denominator. And I want to help you understand that. When you do a common denominator, it's the lowest number they both divide into. The way that you're always taught how to do this in school is to count out your multiples. And if you learn to work with the lowest common denominator, it'll make your work easier. It's actually 20, okay? That's better to do it that way. A lot of students are not solid on common denominators, so they just multiply them together, and it works. It always works. But you want to be better than that. You really do. So what I'm going to do is the best way to learn how to do this is we're going to make that become 20. We make 10 become 20 by multiplying by 2. And you have to multiply top and bottom by the same thing. So that's that. Now you think, okay, what do I need to do to 4 to make it become 20? You have to multiply it by 5. Do the same thing at the top, then you have that.
Okay.
So basically what you have to understand, and a lot of times students never make this connection, 2/20ths is the same thing as 1/10. If that reduces to that. 5/20ths is 1/4. You're changing them so they have the same denominator, then the denominator is a measurement, so it stays. Okay, it's 20ths. 20th stays 20th, and then you do that numerator. So that's what you get.
Okay.
You need to really focus on how to do that way too. Because what students learn a lot of times is teachers will teach them cross multiply. It's a trick, but it's not a good way to teach it because students do it backwards all the time. Your question essentially was that. And what would happen on that is if you do this, you're going to get negative 6 over 40, which reduces to that anyway.
Mm-hmm.
Okay?
But then I might have done it wrong because it's not one of the answers.
Well, you're not done yet because you haven't even, you did the y2 minus y1, but you also have to do the x2 minus x1.
Yes.
Okay? All right.
Okay, thank you.
Fractions, yep.
So that does stay the same then?
Yes.
Okay.
Yes.
Okay, thank you.
I don't like to teach it that way because students, a lot of times, it's a trick. It doesn't teach you any understanding. And a lot of times students do a cross multiply in the backwards. Tricks are, they can be good. But I don't think in fractions. That's not a good way to show that. Oh, I almost stole your pretty pencil. Okay, thank you. Mm-hmm.
So with this one, I was just like I was having trouble processing like no B term. So
Having what?
like having no B term, like where you get like 5-0 or whatever. It's just when it's a perfect square, you just split up the 9.
Oh, this is by factoring.
Yeah.
So that's the one we call a difference of two squares. 49 is a perfect square because it's 7 times 7.
Mm-hmm.
9x squared is a perfect square because it's 3x times 3x.
So like the B term just goes away because of the negative right here?
Exactly. That's why they're plus and minus, because that inner term would be 21. The outer would be minus 21, so it cancels. So that's something that you did really well on your test. That's
it's just like the first one, I just couldn't process it. I don't know if it was a pressure or anything.
May have been. Sometimes you just if the first one, if you don't like the first one, skip it and come back to it. But that's just the factoring. You could do it by the square root property, and you would be doing that right. I mean, you would get 7 over 3. You can tell.
Yeah, and it's 2.3.
Yeah. Okay. All right. You did a good job.
Thank you.
Huh? All right, I'm going to go ahead and get started back here. So just one more simple thing I'm going to show you. And really this section right here, homework-wise, I mean, the biggest thing you got to do is do average rate of change. And my observation of that today was, well, you got to do better on your arithmetic. Okay, I mean, that's just the reality of what goes on. Again, this stuff is pre-calculus information. If you're going to take calculus, you learn about how to do what we call local mins and maxes, and it's real easy. Let me just kind of talk about what we mean by a local min and max. A minimum just means a low point, and a maximum means a high point. But specifically, you have to understand the definition. So a minimum occurs when the function decreases and changes to increasing. So you'll see this on this graph right here. I'm going from decrease to increase, so we would say that that is a local minimum. So there always has to be something going on both sides of the minimum. You decrease, then you increase. It's like, think of a roller coaster again. This is the low point that you hit, okay? Your other local minimum would be right here. Again, you're decreasing and increasing, okay? Students usually understand that okay if you think about it that way. And then a maximum is just the opposite. A maximum means you're going up, you hit a high point, and then you decrease, okay? So these things right here, B and D, would be your maximums, okay? One thing I want you to write on your notes, too, is this is important to write down. An endpoint is never a local max or min. Okay, so I mean, like if on this particular problem, like right here, this graph may come to an end right here. That is not a minimum. We don't call that a local minimum. And the reason we don't call it a minimum is because a minimum has to decrease, then increase. There has to be something going on both sides. So one thing you're always going to see on mins and maxes is something's going on to the left, something's going on the right, and so forth. Okay? So the same thing would apply to this point, this little point right here at the very end. Okay, that is not going to be a maximum at all. Okay, so the idea of min and max, generally like increasing and decreasing, is pretty easy for students to follow. Okay, so just think of high points and low points in the graph, but endpoints don't count. Okay, all right, let's go to the next page. I'll just kind of show you what I'm going to do to kind of wrap the section up. So I'm going to go ahead and review the increase decrease like you did earlier in class. So increase, I'm just going to kind of label those and highlight those. And again, it's the X values that name these things. So it looks like from -3 to -1 is going to be one place where we are increasing. Okay, look at the X values. The other place it looks like is going to be from X equals 2 until you get to X equals 4. So like you did before, that would be 2, 4, would be your other interval where you're increasing, okay? All right, now if you look at decreasing, I see 3 places. I see this place here. I'll do this kind of in blue. I see that region there, and I see that region there. Now, one thing that you want to assume on here, unless I put a solid dot, you want to assume that these things go on forever. So go ahead and just put an arrow kind of at the end of the graphs like that. Make that assumption that they go on forever, okay? All right, so now I'm going to name these with X values. So this first interval is going to be -infinity until you get to -3, forever to the left, and then you get to -3, okay, like that, okay? The next decreasing interval is going to go from -1, and then it's going to end at 2. Okay, like that. So you got that? Okay, and then the very last interval on here is going to be starting at 4. Gosh, I can't see what I'm doing today. 4 to infinity, like that. Okay, is this thing ever constant? No, it's never level. So there's no horizontal line. So that's none. Okay, now all we got to do on this then for a minimum is just look at that. A minimum would be, is there any time the graph decreased and then started increasing? Did that ever happen? Yeah, how many times did it happen? Twice. That's a minimum, that's a minimum. Now all I want you to do is just name the X value on that, or the points. You can do either one. I guess I'm saying points on here. So what I'm going to do is just kind of, this is a minimum right there, at that point right there. So that point seems to be -3, -2. Okay, so that's what one of your minimums is. The other minimum is right here. That looks like that is the point. It has an x value of 2, and it has a y value of -6. Okay, so you do have two minimums on that, 2 and -6. Okay, name them with points. If I ask you to name them with points, do that. Okay, so what is a maximum? A maximum is a high point, but technically the graph is increasing, then decreases. Does that ever happen? How many times does it happen? Twice, right there. Increase, decrease, increase, decrease. Okay, so that point and that point are going to be your maximums. Okay, all right. So we would have a maximum at this point, which looks like it is -1, 2. And then the other maximum right here looks like that is going to be the 0.45. Okay, so just name the points. All right, is everybody okay with that, you think? Okay, all right. Let's go ahead, let me kind of go through one more here, because there's a few things that can happen on these. So again, increasing, I'll just sort of highlight that in yellow, and I'll write the intervals as I do these. Okay, so that's going to be -infinity until I get to -1. Okay, just kind of name the intervals as you do them. And then the second one, it looks like here to, now you got to watch this carefully, and I'm not going to be picky in college algebra about this. In calculus, I'd be a little more picky. But it would be okay on this one to just say, okay, from 0 is where it starts, and then all the way, that looks to me like it's 3.5. I'm just kind of guessing that if I take that high point, that looks like it's 3.5. And that whole entire area right there, you may think we're constant there. That's not really what's supposed to be happening. This is a bad graph. I could have given you a better example. I'm just going to kind of assume that right at that point right there, it kind of levels off and it just keeps increasing. Okay, yeah.
You write the view and then add it to increasing.
Oh, I put it in the wrong place. Okay, thank you. Okay, all right. Okay, so I should write it like this. Okay, so we would say -infinity to -1 and then 0 to 3.5. Those are the two places where we're increasing. Okay, yeah. No, I can see how you see that. That's why I was saying it's not a real good example of a graph. I was trying to find something where it was level just for one point. But you know, on this, you could do this if you wanted to. And technically, like in a calculus class, you would write this, instead of writing that interval like that, you would write it as 0 to 2 and then 2 to 3.5. And that's kind of what you're getting at, which is a good observation. I mean, this place right here, the slope is kind of like 0. So I don't care which way you do it. You could do 0 to 3.5, or you could do 0 to 2, then 2 to 3.5. I know that's what you're thinking, and that's a good observation too, okay? But either way for college algebra will be okay, right? Decreasing, okay? I think that's pretty solid on decreasing. So it looks like we're going to have -1 to 0, and then the other one will be 3.5 to infinity. Okay, when with this one constant, I'm going to say none. It doesn't look like there's an interval where it remains constant. It looks like maybe at x equals 2, it's just for that one instant, it kind of levels off. Okay, all right. So does this thing have any local minimums? And remember, a local minimum is decrease, hit a low point, increase. Does that ever happen? How many times does it happen? Once, right there, and that's 0. So that it would be 0, -4. So you do have that minimum at 0, -4. Okay, so that's your minimum. Okay, what's a max? A max is increase, hits a high point, decrease. Does that happen? How many times? Once, good. Okay, so you have a max here. That max would be at 3.5, okay, that is at 3.5 it looks like. Now that y value, what do you all think? Is that a 4? Can I just say 4? Yeah, I'll just say 4. It's hard to tell. Okay. All right.
So the other point, of -1, 0, that's not considered a max?
It is. I didn't see that one, but now I do. Okay, thank you. This right here is a max. Yeah, that one's going from increase to decrease. So that point would be -1, 0. Okay, like that. Yeah, so you do have 2 maxes. Okay, and you have 1 min. Okay, this thing right here is not a max or min because the graph is just increasing. So it's got to change directions. Okay, all right. So see if you can do the last 2 okay, and then we'll go over that, and then we'll get started on the next section here. And maxes and mins, you're always going to usually name with points, intervals, exponents. Yeah, it's just going to keep increasing. I mean, for that, now that wouldn't be a max or min or anything, but this whole thing is going to increase from there to there. The y values just keep getting bigger. That's what you're kind of thinking of that, what I did on the problem I just did, kind of in reverse. And really, you know, max is always increase, high point, decrease. So that's got max. Yeah. And then decrease, increase. Okay. Okay, so you can kind of look and see if you did what I did. There's a few little differences on the second one. So increasing, I used like -1.5 to 2, and then I did 4 to infinity. Okay, so there's no other way to write that. You got to have parentheses on that. Decreasing, I missed it. What did the teacher miss? Hope you guys had one other place we decrease. That should be negative infinity until you get to -1.5. I don't care which order you do that in. So there's 2 places where it decreases, okay? As far as the mins, the 2 low points were -1.5, -4, and then 4, -1, okay? The only max that I see is 2, 0. Okay, we okay with that? Okay, we get anything different? Okay. All right, now the second one, the way I did this is like this. The increasing would be this part here that I have in yellow from -1 to 0. You could, I'm not sure how picky WebWork's going to be, but because that's a solid dot, you could put a -1 in a bracket there. I don't care which way you do it. Technically, to me, it's a parenthesis, but I see disagreement sometimes in textbooks, okay? And then the other thing on that is you're also increasing from 1 to 5, okay? And you're always increasing there. You don't have to break that up into 2 intervals. You also could do 1, 5 with a bracket, okay? So I don't know if WebWork will take it both ways. I would take it both ways. And then decreasing would be 0 to 1. You're never constant on that. And then the only maximum is at 0, 0. And then your minimum is at 1, -2. Okay? Okay?
Still have increasing at 1 to 3.
You could. I think what you might be thinking is you could have 1 to 3 and then 3 to 5. You don't have to do that. It's not, it really is wrong. No, hold on. That gets into a technicality that I don't want to go to. All right? And that's because like in a calculus class, we would probably break that into 2 intervals. There's a reason. But I would take it that way, okay? It's okay. You just don't have to do that. The y values are getting bigger the entire way. And you won't see that kind of thing on WebWork. Okay, we have any problems? Yay, nay? Okay, we're doing pretty good. Let's go to the good stuff now.